In Unit 7, we're going to talk about proportions, and the first thing we're going to talk about in Section 1 is I can identify and solve proportions. So let's write the word proportions right here, and then let's do the warm-up. So in the warm-up it says, when somebody says ratio, what should you think? And of course we should think a fraction. A ratio is a comparison between two numbers. We put one on the top and one on the bottom. So normally we're going to think of that as a fraction. Next thing we're going to do is we're going to solve this equation right here. Now remember, this is a short fraction bar, so it groups the x and 2 together. We're going to move the 11 to the other side. So I'm just going to subtract 11 from both sides. Of course, it's going to cancel off over there. And then we're going to have x over 2 equals, this ends up being a negative 4 on this side. And then I'm going to finish this off by multiplying both sides by 2. Again, I'm going to put the second one in parentheses on each side. Of course, these cross cancel. So we end up with x equals negative 8. So I'm going to go ahead and circle that. Let's see. So in the next question it says, in elementary school you learned how to change a fraction into another equivalent fraction. It says, do you remember how? So let's stop and think about this. How would we change this into another equivalent fraction? Well, on this one we'd probably just reduce this. So 4 goes into here into 4 once, and 4 goes in here twice. So we end up with 1/2. So one way we can do this is we can divide the top and bottom by the same number. Or if it's already reduced and we needed to get, say, a common denominator or something like that, if we wanted to multiply the top and bottom by 2 or something, we could multiply here and we'd get a 2, multiply here we get a 6. 2 sixths is the same as 1/3. So we're going to write this down. We multiply or divide top and bottom by the same number. And I'm just going to use a hashtag for number sign there. All right, so that's how we can change one fraction into another equivalent fraction. And then for the next couple it says find the missing number that will make each problem a set of equivalent fractions. So if you're pretty good at these, you might already know how to do this. I'm going to go ahead and fill in the numbers here. This one's going to be a 6. And if you want to take a pause and see if you can figure out what these other ones are, that would be fine. This next one here is going to be a 30. And then the last one over here might be the most difficult one of these. It ends up being a 9. Now, if you don't know how to do that, or wondering how we did that, that's what we're going to talk about today. We're going to talk about how we can solve a proportion, and it has a heck of a lot to do with equivalent ratios or equivalent fractions. So let's talk about what a proportion is. A proportion is an equation. So let's write the word equation right here. A proportion is an equation, and what it does is it sets two ratios equal to each other. So remember, a ratio is a fraction, so it's got a fraction on one side of the equal sign and a fraction on the other side of the equal sign. So you'll notice we've kind of already dealt with a couple of proportions right here, and it says like any equation it can be true or false. Well, we want all the proportions that we work with, we want all of them to be true. We definitely want to be working with true proportions. In fact, when we normally say something like this, when we say two ratios form a proportion, what we mean is they form a true proportion. They are indeed equal fractions, equivalent fractions. So if two ratios form a proportional relationship, that's the same as saying they are equivalent fractions. So let's write the word equivalent right here. And let's just think about this for a second. If we're talking about a proportional relationships, or two equations, or two fractions that are proportional, what we're talking about is two fractions that are equivalent to each other. Two equivalent ratios would be another way to say that. So how do we tell if two fractions form a proportion? Well, let's take a closer look at the warm-up question, and we'll notice a couple of patterns in some ways that you might have thought of how to solve these, and then maybe some ways that you didn't think about how to solve these. So let's first talk about a scale factor. And there are lots of different ways that we can use a scale factor, so let's talk about this right here. I noticed that on this one, if we start off with a 3 and then it turns into a 12, so to go in this direction we would have to multiply by 4. Well, we want to know what number this is right here, so we kind of have to go the other direction. If we go the other direction from 12 to 3, we divide by 4. So let's take the 24 and divide by 4. So if we divide the top by 4, we end up with a 6. That's the right number right there. That's what we end up with there. Let's do the same thing over here. If we go from 4 to 20, we do that by multiplying by 5. So we're going to go this direction here. We're going to multiply by 5, so we end up with a 30. You'll notice that that matches up above. Okay, and then on this one right here, we're going to need to go this direction because that's the same direction that we want to figure out this missing piece right here. So to go from 15 to 5, we would divide by 3. So let's go in that same direction here. We're going to divide by 3, and 27 divided by 3 is 9. Okay, so that's how we filled in those numbers right here, or at least one way we filled them in. So what we can do here using a scale factor is we can multiply or divide to go from top to top or bottom to bottom. So from top to top or bottom to bottom. So we went from top to top here by either dividing by 4 or multiplying by 4. We did the same thing on the bottom. Here to go from bottom to bottom, we multiplied by 5, so we did the same thing here. We multiplied by 5 there, and then divided by 3 here, so we're going to divide by 3 there. So that kind of keeps it consistent and that sort of thing. There is another way that we could do this. We could look at this and we could say, all right, well, how do we go from the bottom to the top? Well, to go from bottom to top, we multiply by 2. So if we go from bottom to top, we multiply by 2. So we end up with a 6 right there. You can do the same thing here, but it gets a little more tricky. You'd actually have to multiply by 1.5. So we're going to multiply by 1.5. All right, let me make that dot look like it's in the right spot there. And again, doing that on these problems is not too bad. This one's easy, this one's not too bad. This one's kind of a pain in the butt because to go from 5 to 9, you have to multiply by 9/5 and then some weird stuff there. So that gets a little bit more difficult. So scale factors are useful, but what we're going to talk about next comes in really handy. And what we're going to talk about is cross multiplying. Okay, so we can cross multiply. This is sometimes called the butterfly method. I've heard people call it. I've also heard people call it the heart method, and you'll see why in just a second. So one way to solve this problem is to say, look, we're looking for this guy right here, and then we do something really cool. We literally cross multiply. So I'm going to take the two of these and I'm going to multiply here, so I end up with 12x, and then I'm going to multiply here and I end up with 3 times 24. Alright, so when we multiply over here, then we've got a 12x over here and a 3 times 24. We're going to finish solving this by dividing by 12. Now you'll notice that I purposefully did not go ahead and do the multiplication because I know what's going to happen right here is I'm going to end up with a 24 and a 12. I'm going to go ahead and do some cross canceling here. So that's going to be a 2, so I end up with x equals 6. So that number there's got to be a 6. And then I'm going to do the same thing on this one. So again, we multiply here and we multiply here, and we end up with a 6 times 20 on this side and a 4 times x on this side. Then I'm going to go ahead and divide by 4 so I can get the x by itself. Those of course are going to cancel, and I'll notice that I get some cross cancellation going here. 4 goes in here once, 4 goes in here 5 times, so I get x equals 30 on this one right here. And then we'll finish this last one off. We're going to multiply here and we're going to multiply here, so I end up with a 5 times 27 on this side, and then on the other side I end up with a 15 times x. We're going to go ahead and divide by 15, and you'll notice some patterns to this. It kind of works the same way every single time. I am going to do some cross canceling here. 5 goes in here once, 5 goes in here 3 times, but then notice I've got something in common with the 27 and the 3. 3 goes in here once, 3 goes in here 9 times. The only thing left on the bottom is a 1, so I don't have to write that, so I end up with x equals 9. So you'll notice that I get the same answers on each one of these doing either method. Okay, so I do want to show you one more thing, but before I show you that, I want you to notice why some people might call this the heart method or the butterfly method. Kind of looks like a heart when you make this shape, and then some people kind of swing this around and kind of make it look like you've got a loop over here and a loop over there. So it would kind of look like a butterfly, but either way, you can call it whatever you want. That's called cross multiplying, and that's how you solve that. I do want you to notice one more thing, and that is the sum of the numerator and the denominator. So remember, this is a 6, this is a 30, and this is a 9. So if we add these up, we end up with a 9. If I add those up, I end up with a 36. If we add these up, we end up with a 10. If we add these up, we end up with a 50. And if we do the same on the last one, we add these up, we end up with a 14, and add these guys up, we end up with a 42. Okay, now I want to slide back here and I want you to take a look at this right here. So you'll notice that on this one, to go from the bottom to bottom, we multiplied by 4. Well, watch what happens if we multiply by 4. So if I multiply that by 4, I end up with 36. And think about what we'd multiply from here to here. We'd have to multiply by 5 to go from 10 to 50, and that's the same thing we multiplied by here. And then on this one, going this way, we divided by 3, or we could go this way and we could multiply by 3. So there's kind of this cool relationship between the tops and the bottoms, and then the total, the sum of the top and the bottom, the sum of the numerator and the denominator. So on today's assignment, it's going to be pretty simple. All you need to do is determine whether these ratios form a proportion, and then you need to show some work or give a reason for that. And you can use either that cross multiplication, or you can use the scale factor method. Either one would be just fine. So on this one, I'm going to use the scale factor method. Okay, you'll notice that we multiply by 2 here and we multiply by 2 here. So the answer on this one is yes, that's going to be a proportion. On this one right here, I'm going to use this cross multiplying method. So 4 times 11 is 44. And then over on the other side, we're going to have 9 times 6, that's 54. Those are not equal, so the answer on that one is going to be a no. And then we'll take a look at the next one. I'm going to go ahead and multiply here, because anytime it gets a little bit sticky, I'd rather work with the cross multiplying here. So this is going to be 22.4, and then on the other side we're going to have 4 times 5.6. So 4 times 5.6, I'll go ahead and use the parentheses there. And I'm going to grab a calculator, and we're going to go ahead and do 4 times 5.6. Make sure the calculator looks right, hit enter, and we get 22.4. So those two things do equal each other, 22.4. So the answer on this one is a yes. So these are proportional, these are not, and this last one on C, that one is a yes. And then it says solve each proportion. In other words, find the value that makes each proportion, and the word here is true. We want each one of these to be a true proportion. So when we multiply here, I'm going to multiply this 21 times x, so I'm going to multiply that and just write down 21x, and then I'm going to multiply the 7 times the 12. And just as a reminder here, a time saver when you're solving proportions is to not multiply the numbers together. It's also a good practice to cross cancel. All right, so practice cross canceling. So let's take a look at this right here. If we divide both sides by 21, 21, got to write that correctly. So here's the advantage. We know we're going to need to get rid of that number in front of the x, so we're going to divide by 21. But why multiply these numbers together and get a huge number, a bigger number than 7 or 12, when we can go through here and we can cross cancel? So notice I've got a 7 and a 21, so that would be a 3 down here. 7 goes in here once, 7 goes into 21 3 times. And then I can just do 12 divided by 3, and I end up with 4. And that right there is the correct answer for this problem. So we get x equals 4. And then let's take a look at the next one. Again, we're going to do the cross multiplication. We're not going to multiply these together. We're just going to write down what the problem is. And then over here we have 63y. We're going to divide both sides by 63. So those are going to cancel, and I end up with y equals. And then let's do the cross cancellation here. Whatever you notice is just fine. If you notice 7 goes into both of these, that's okay. I kind of like taking this one right here. 9 goes in here once, 9 goes in here 7 times. And then I've got 49 divided by 7, which is pretty easy. We end up with a 7 right there. And then this last one, you'll notice we've got a decimal on this one, so we'll have to be a little bit careful. So we're going to multiply here. This is 13 times 56. And then on the other side, we've got 11.2n. And then we're going to divide by 11.2. So I'm just going to write down the n equals, and then I'm going to grab the calculator and let's plug this in. So we've got, we want to do all of this. So I'm going to do the entire top. This is good practice here. I'm going to do 13 times 56. That's going to take the entire top, put it in parentheses. That's going to make sure that the calculator figures out what the top is and then divides it by whatever the bottom is. The bottom is 11.2. So we hit 11.2, we hit enter, and we end up with 65. So we've got 65 right there. So we've got a 4, we've got a 7, and we've got a 65 on this. And then the last question is more of a thought question. Can you think of why cross multiplying works? This is going to be the technique that we're going to focus on most of the time. So why does cross multiplying work? Well, think about that for just a second, and think about the way we solve equations, because that's really all this is. This is just an equation with one fraction on each side. And think about the steps we use to solve equations. So I'm going to come down here and we're going to take a look at this, and I'll show you why cross multiplying works. Okay, what we're really doing here is we're doing this. We're multiplying both sides by something that will cancel off the denominators. Well, the denominator here is 4. I really don't like working with a denominator of 4, so we're going to multiply this side by 4. And the denominator over here is 20. I really don't like working with a denominator of 20. So what we're going to do is we're going to multiply both sides by 4 times 20. So you'll notice that we're doing the same thing to both sides, and if you want to put both of them in parentheses, that's totally okay. And I want you to watch what happens here. I can now cross cancel the 4 with the 4, so I end up with 20 times 6 on this side, and I can cancel the 20 and the 20, and I end up with 4 times x on this side. So that would be the same thing as if we just did 20 times 6 and put it on this side, did 4 times x and put it on this side. Let's see if that works again over here, and you'll notice this one is a little bit different. It's got a variable in the denominator, but that's totally okay. We can work with that. I'm going to multiply by a 27 and a y, a 27 and a y. The y's are going to cancel here. That's going to leave a 27 times 5 on this side. And the 27s are going to cancel here. That's going to leave a 15 times y on this side. So you'll notice that would have been the same as just taking this cross-multiplying shortcut. 27 times 5, put it over here. Y times 15, we always put the coefficient in front, so we get 15y there. Okay, this is what your assignment is a lot like. It's about identifying whether or not these are proportional, okay, and then actually solving a proportion. And then we're going to pick up and do some more of this tomorrow with some more complicated ones. All right, thanks.